Now in lecture 1 of the chapter electrochemistry, I have discussed the different types of electrochemical cell, that is galvanic or voltaic cell and electrolytic cell, and I have started discussion with the galvanic cell, and the latest topic which we are discussing is the terminology section. That is, we must make ourselves acquainted with the terms that are related to this galvanic cell. So we found that oxidation is there, reduction is there. So a cell reaction is associated with a redox reaction, obviously, since we need electrons which will move through the external circuit and will give you current. Now in this connection we have seen that an electrode is necessary which connects the external circuit with the chemical system, and this electrode here, if oxidation occurs, then it will be referred as the anode, and if reduction occurs, it will be referred as the cathode. And this type of reaction where there is loss of electron will be termed as the oxidation, and the cell in which this will occur will be termed as the half cell, oxidation half cell, and the reaction is oxidation half reaction. And where the electrons will get accepted, it will be reduction, and it will be the reduction half reaction, and the cell in which this reduction half reaction will occur will be termed as the reduction half cell. Now combining these two half cells, the oxidation half cell and the reduction half cell, we will get the complete cell. And combining the oxidation half reaction and reduction half reaction, we will get the cell reaction. Now another thing is the oxidizing agent. Now this zinc is releasing electron. Just for example, I am taking this cell reaction. So zinc is releasing electrons, so it is reducing copper. So it is the reducing agent here. And copper is accepting these electrons, thereby oxidizing zinc. So it is oxidizing agent. So these are the associated terminology. Now let us discuss the difference between the galvanic cell, that is the voltaic cell, with the electrolytic cell. I have discussed it in the previous lecture also. Just a revision, and for more clarity, let us. So we have galvanic or voltaic cell at the left, and say electrolytic cell at the right. Now the first point is what it performs. It gives you electrical energy from chemical energy. And what it gives you? Here you get chemical energy at the cost of electrical energy. Now here the source of electron is the spontaneous reaction that occur within the cell. In case of galvanic or voltaic cell, the electron which we get in the external circuit is owing to the spontaneous reaction that occurs within the cell. And here the source of electron is the direct current applied externally with the help of a battery. So Here the source of electron is external, here the source of electron is internal. Now, chemical reaction is giving the electricity. But here, electricity is executing chemical change. So, electricity is applied externally and it is executing the chemical change within the cell. Now, we have examples. I have told you in the previous lecture. Examples are the Daniell cell, dry cell, etc. And here the examples are the Kastner-Kellner cell, down cell, where we can synthesize various chemicals like NaOH, Cl2, etc. and also for electroplating and refining. So there are various types of electrolytic cells like down cells, just I have mentioned. So these are the examples. And the fifth one is the oxidation and occur generally in two separate compartments. So we have, obviously we will have a redox reaction that will give rise to the electric current, and the oxidation and the reduction will generally occur in two separate compartments. One in the oxidation half cell where the oxidation will occur, and in the reduction half cell the reduction will occur. Now in case of electrolytic cell, the redox reaction generally occur in a single compartment. And the last one is the terminal sign of anode and cathode. And in the previous lecture I have told you that don't memorize the charge of anode or cathode, or don't categorize anode or cathode by its charge or the terminal sign. The thing is, anode is that electrode where oxidation occurs, and it is true everywhere. So anode is that electrode where oxidation will occur. It is true for both the galvanic or voltaic cell, or in case of a electrolytic cell. Now here it is negative electrode. Since we have electrons in the external circuit from this cell, so electron must evolve from the electrode. So to have the oxidation, it must be anode which is the negatively charged electrode. So only if it is a negatively charged electron, then only it can release electron, and if it releases electron, it will be referred as the oxidation. So this will be positive one. So you see, charge may vary, terminal sign may vary for anode. So don't memorize anode by that anode is the positively charged electrode or anode is the negatively charged electrode. If you say it, then you must associate the cell type. That is, if you say anode is negatively charged electrode, then don't forget to tell that I am saying it for a galvanic cell. And in a similar way, if you mention that anode is a positively charged electrode, then I suggest you don't forget to tell that it is for a electrolytic cell and not in general. Now here you have oxidation, but it is positive since you are supplying current externally. You are supplying electron externally, and the electrons which go to the cathode section will carry out the reduction process, and in anode it will extract electron. So here, with the help of positive charge, electron is forcefully extracted from the chemical species. So the electrolysis takes place. So it must be positive electrode. Now obviously the cathode will be with the reverse sign, but remember it is that electrode where reduction will occur, and it is true for all the cell types. Cathode is that electrode where reduction will occur. But you see, if it is negative, then it must be positive. So it is a positively charged electrode and it is negatively charged electrode. So this is the difference between galvanic cell and electrolytic cell. Now there is another difference you need to know, that is the irreversible cell and the reversible cell. What is that? So what do you wish from a cell? You have a solution here, aqueous solution of electrolyte, and here you have a metal rod, here you have another metal rod, so that these two are playing the role of anode and cathode, and you have an external circuit here. Here you have a ammeter, a switch. Now, if it is a galvanic cell, then it is going to give you electrons with the help of a spontaneous reaction that will occur within the cell. So it will be associated with a potential, that is tendency to give up electrons, and this potential will play between the two electrodes. Now let it be E. So E is the potential of the galvanic cell. Now to find whether it is reversible or irreversible, to find whether the cell is reversible or irreversible, what you have to do, you have to connect a DC here, that is direct current source, here in the external circuit, and let E prime be the potential of the DC source. So you may have a AC to DC converter and connect it to the main line, or you may apply battery here to have the
desired potential. Now, three cases may arise. Case 1 is that E greater than, let the first case be equal. So say E equals to E prime, that is the potential of the galvanic cell is equal to the potential of the direct current source. So what will happen? Here anode is pushing electron in this direction and cathode is extracting electron in this direction with the potential E. This is the characteristic of this galvanic cell. But this direct current source is so connected that it is pushing electron in this direction and it is extracting electron in this direction with potential E prime. So it is an opposing force. It is connected in such a way that it opposes the phenomena that is occurring in the galvanic cell. Now if the two potential become equal, then what will happen? Then the tendency to release electron by this anode will be equal to the tendency to release electron by this direct current source, and since these two are in the opposite direction, what will happen? There will be no net flow of electron, that is current. Now in a cell we have two electrodes, electrolytic solution, and in the external circuit, if this is anode, if this is cathode, if this is negative, electron will travel from this anode to cathode, and as per convention, current will flow from cathode to anode. So there will be no net flow of electron, that is current, in the external circuit. It will happen so. Now case 2. Case 2 is, let us decrease the potential of the external power source. Let us decrease the potential of the external direct current power source by a very small amount, by an infinitesimally small amount. So then potential of this galvanic cell is greater than that offered by this source. So there will be cancellation and the tendency of this galvanic cell being greater to release the electron, there will be a net flow of electron from anode to cathode. So spontaneous reaction, or rather using the term spontaneous, since the difference is very less, reaction will occur in the cell so that we will have electron in the external circuit. So there will be reaction occurring in the cell. Now in absence of this DC, the rate at which the reaction will occur will be greater than this one, since there is a cancellation between these two opposing forces, and since this one is greater, reaction will occur but not at that rate which will occur in absence of this power source. Now case 3. Case 3, it is E less than E prime. Now we are increasing the potential of the external power source by a very small amount than the galvanic cell. So the tendency of releasing electron by this DC in this direction is greater than the tendency of this anode to release the electron in this direction. So the opposing force, the external opposing force is greater. Then what will happen? It will extract electron from cathode and it will forcefully put in this anode. So the reverse reaction will have to occur. Reverse reaction will occur. And when the reverse reaction will occur, what you are actually getting is the electrolysis. Instead of getting spontaneous current from the galvanic cell, if you connect it to a direct current source, what you are causing to it? You are converting the galvanic cell to an electrolytic cell. Now, if this cell allow you, or it has the characteristic of reversing the reaction, then only it will be considered as the reversible cell. So for an electrochemical cell to be reversible, these three criteria must be followed. That is, when it is equal, there must be no net flow of electron. When the external is less, there will be flow of electron, so that it will act as the battery, it will act as the power source. And when the external power source will have a greater potential, then the reverse reaction must occur. That is, the cell reaction which is occurring in this galvanic cell must take the reverse part. That is, the backward reaction will occur. However, the backward reaction is actually electrolysis. So you are spending electrical energy and you are getting chemical energy. So if these three conditions are followed, it will be reversible cell. And if it is not followed, so these three criteria, if it is followed, it is reversible cell. And if it is not followed, then it will be, if it is not followed, then it will be irreversible cell. So that is the difference between a reversible cell and a irreversible cell. Now you can think that if you have a reversible cell, you can use it as a rechargeable cell. You can recharge it, since when there is need of current, you just connect that cell to the circuit and you absorb the electricity. So there will be spontaneous chemical reaction within this cell, and it will give you electrons and you get the desired electricity. Now when it's discharged, if you connect it to a direct current source having a greater potential, what you will get? The reverse reaction will occur and the supplied electrical energy will be stored within this system in the form of chemical energy, so that in absence of this external power source, you can again use it as the galvanic cell. So that is the case which occurs in our home inverters or car batteries or your mobile smartphones. What is happening there? They are all reversible cell. Since when you are running the smartphone or there is load shedding in your house, there is a power cut, the inverter is giving you electricity through the spontaneous chemical reaction that is occurring within the cell. So there is a spontaneous conversion of chemical energy to electrical energy. So you are enjoying this electricity to make your life simple. That is running a fan, running smartphone. However, running smartphone can be actually makes life complex. So let us understand the mechanism of inverter. So when there is load shedding, power cut, you are using the electricity out of this chemical energy. Now when the power comes back, what will happen? The direct current source, there is a converter within the inverter machine, so it will apply a direct current source and it will forcefully through supply of electron with a greater potential, it will cause the reverse reaction to occur, so that electrical energy will be converted to chemical energy and it will be stored as a backup for the coming power cut. So this reversible reaction can lead to the formation of inverter batteries, smartphone batteries, car batteries, that is rechargeable batteries. But irreversible batteries are, the examples of irreversible batteries are a dry cell. You bought a pencil battery, you use it and you have to throw it. Now don't try to charge that irreversible battery, since some other reaction will occur and it will cause excessive heat and it may explode. It may explode, not guaranteed that it will explode, it may explode. So if it is reversible, if it is written that it is rechargeable, then only attempt the charging process. So in conclusion, we can say that a reversible cell will give you, can be used as a rechargeable cell, and an irreversible cell is a use and throw one. Now the examples of reversible cell are Daniel cell, inverter battery, smartphone battery, and the irreversible are dry cell, simple voltaic cell. Now I will come to the simple voltaic cell in the next lecture.